All right. Hello, Hashi Talks. We are very excited to be here. Some quick introductions before we dive in. My name is Denise Yu. I work at HashiCorp as the engineering manager of the Terraform developer experience team. We build the Terraform Plugin Framework and also other tools that enable anybody in the world to build a Terraform provider.
And my name is Polina Jastrzebska. I'm a senior engineer at HashiCorp, and I lead the development of third-party integrations for HCP Terraform. My work enables Terraform to be leveraged across various platforms and systems, such as ServiceNow, Splunk, Kubernetes. I'm a member of the hybrid cloud team here at HashiCorp, and along with many other teams, we work on Terraform. More specifically, we work on Terraform ecosystem, which means all of the providers, integrations, and tools that connect Terraform to the outside world. We are adding more and more integrations as more teams need to manage complex infrastructure across multiple clouds and data centers.
So you can visualize the architecture of Terraform Core and the ecosystem like this. Terraform Core, which is the main HashiCorp/Terraform repository, contains all of the business logic and state management for Terraform. The API layer that connects Terraform Core and all the providers follows the provider protocol specification. And providers are the lifeblood of Terraform. Without providers, there is no Terraform. But did you know that until a few years ago, providers actually used to be part of the Terraform core codebase? If you go way back in the Terraform repo's Git history, you will find evidence of a baked-in AWS provider. The decision a few years ago to split providers out from Terraform has enabled a decentralized architecture that empowers practitioners to choose whatever providers they need for their infrastructure needs. Today, Terraform is the default choice for managed infrastructure at enterprise scale, with countless providers available off the shelf. At the time that we wrote this talk, there were 4,850 providers in the Terraform registry, and dozens of new providers are published every week.
In addition to the provider ecosystem, we've been shipping tons of new integrations to help Terraform meet our users where they are today. In the next portion of the presentation, we will talk about Terraform integrations. These are applications designed to bring Terraform capabilities to various third-party systems and platforms. Over the past few years, we've seen remarkable growth in demand for such solutions because organizations out there develop more effective infrastructure automation pipelines. HCP Terraform offers a robust set of APIs, which allows us to build these powerful applications. Although we didn't introduce any new integrations this year, we delivered significant updates to our existing ones. The Terraform ecosystem includes a variety of integrations. Here, I want to highlight our ServiceNow apps for Terraform. These are free plugins built entirely on the ServiceNow platform, and they can be installed from the ServiceNow store. ServiceNow is a widely used ticketing platform that provides digital workflow automation. By connecting your ServiceNow instance to your HCP Terraform organization, you can interact with your Terraform state, and you can start and apply Terraform runs directly from the comfort of your ServiceNow interface. The first ServiceNow Terraform application, and our longest standing one, is simply called the Terraform app, also known as the ServiceNow Service Catalog for Terraform. It's a service catalog inside of your ServiceNow instance, which lists the cloud infrastructure items and services available to order from that catalog. End users can request a Terraform workspace and provision resources like databases or storage buckets within that workspace. The experience is similar to online shopping, where users can select an item from the list, add it to a cart, and submit in an order that can later be tracked. And users don't have to know anything about Terraform or how this app is configured at the core. This app is particularly popular among organizations that require limited user access and tighter control over infrastructure security, such as companies in the public sector, finance, banking, healthcare. It's because the app checks two important boxes for them. It allows ServiceNow admins to target specific user groups with roles and permissions, and it also provides extensive logging to ensure that valuable audit trail for compliance purposes. In April last year, we introduced a major enhancement, integration with Terraform no-code modules. This allows users to provision no-code workspaces directly through the service catalog, which makes it a lot easier to deploy infrastructure without writing any Terraform code. It streamlines the process by enabling teams to use pre-approved modules. And since these modules are published in the Terraform private registry, ServiceNow users only need to reference the module name in a simple user form to build the defined infrastructure. If you'd like to learn more about the no-code provisioning with Terraform and how you can use it through ServiceNow instance, check out this hands-on tutorial. Our second ServiceNow Terraform app is the Service Graph connector for Terraform, which complements the service catalog. With the ServiceNow Service Graph connector for Terraform, you can automatically import resources from HCP Terraform or Terraform Enterprise into the ServiceNow Configuration Management Database, CMDB. It gives you a centralized view of your organization's Terraform resources so you can manage them alongside the rest of your IT assets. The application pulls your Terraform resources from the Terraform state file and displays them in the ServiceNow dashboards. Last year, we introduced significant security enhancements, making sure that the information about your infrastructure is transferred safely and securely between platforms. For our Kubernetes users, we have the HCP Terraform operator for Kubernetes. It lets you manage HCP Terraform resources with Kubernetes custom resources. This means that you can provision infrastructure inside or outside of your Kubernetes cluster right from the Kubernetes control plane. With the operator, you get all the benefits of HCP Terraform, like proper state management, locking, sequential execution of runs, or secure secret injection, all seamlessly integrated into your Kubernetes workflows. It works with both HCP Terraform and Terraform Enterprise, making it easier for platform teams to provide a Kubernetes native experience while keeping everything standardized on Terraform. Over the past year, we've made some key improvements to the operator. You can now initiate Terraform workspace runs declaratively, and we've also enhanced agent pool management. So you can create and manage agent pools directly as part of your Kubernetes infrastructure. Plus, we've improved auto-scaling, giving you more control by letting you configure scale up and scale down times separately. To learn more about our Terraform integrations, you can check out our documentation.
So let's talk a bit about the big user problems we've addressed this year in terms of new features coming from Terraform Core and fanning out to the provider ecosystem. Hey, Polina, have you ever used Terraform's built-in functions, such as trying to get the maximum integer from a list?
I have. In fact, I use functions all the time. Terraform ships with a pretty large set of available functions, somewhere in the range of 115 functions. But sometimes you need inline functions that are a little more complex than just parsing a string with a regular expression.
And the internet agrees. So one of the first things we landed in Terraform Core in 2024 was provider-defined functions. We introduced a new protocol specification to enable provider authors to bring their own functions.
Putting function definitions into the hands of provider authors enables us to do some pretty cool domain-specific things. If you've used AWS, you've probably had to manipulate a string or traverse a JSON object to find a corresponding ARN, Amazon resource name, at least once. Now ARN lookups ship natively with the AWS provider, among many other quality of life functions.
And check out the provider-defined function to decode manifests inside the Kubernetes provider. You can basically marshal Kubernetes configuration YAML into a Terraform object and then traverse that object in other parts of your Terraform configuration. Provider-defined functions shipped in Terraform 1.8, and many official providers now ship with functions. So if you're a provider author and you want to learn more about how you can leverage provider-defined functions, here are some links to tutorials and documentation. In addition to extending built-in functions, we tackled a second big user problem this year. For longtime Terraform practitioners, this is probably one of the more well-known challenges, particularly if you're using Terraform to manage infrastructure for multiple application teams who each have their own sets of credentials that they need to manage. Terraform doesn't do anything terribly clever with the data that you give to it. Generally, everything you express in configuration will end up in the state file, which includes variable names, configuration parameters, and of course, anything sensitive like secret passwords and keys. You can mark your variable as, being sensitive true, but so that prevents it from being logged out to the terminal output during Terraform apply, but it's still going to end up in the state file. Today, encrypting the entire state file is one possibility. In fact, lots of Terraform backends, such as AWS S3, encrypt data at rest by default today. But encrypting the entire state file doesn't actually address the core of the issue for practitioners. First of all, if you're performing the encryption and decryption yourself, you are now in the business of managing the full lifecycle of your encryption key. Also, you still need to reason about encryption in transit to have end-to-end security. But finally, and most importantly, this approach fundamentally shifts the onus of securing secrets to the practitioner. So we thought we can do better than that. So while Terraform manages the infrastructure resource that contains a secret, Terraform handles the create, read, update, destroy operations. It stores the remote object in state in accordance with the provider schema, and it reads the state back out during every operation. It compares configuration versus state versus reality to detect drift. Terraform may not actually need to manage the secret value itself. So what we've built and shipped this year in Terraform 1.10 and 1.11, which is coming very soon, is a two-punch feature set of ephemeral values followed by write-only attributes. Ephemeral values are a new way for practitioners to indicate to Terraform in configuration that a certain value is for short-term use. An ephemeral value is one that is used in the next run, but never committed to state. The term values is sometimes, I know we use that term a lot, it's pretty overloaded, so let's clarify exactly how this feature is used. Variable definitions can be flagged as ephemeral with the ephemeral equals true attribute. You can similarly mark an output as being ephemeral. These values can then be consumed by managed resources or local variable blocks, or even when you configure a provider. You might notice in the second example here that there's another new abstraction here, actually. Ephemeral as a new keyword didn't exist previously, where it says token equals ephemeral.aws KMS. So that brings us to the next thing, which is we've also introduced the new concept of ephemeral resources. Provider authors can now define a resource as being ephemeral, and practitioners can provision them using the new ephemeral language. This signals that the entire resource is going to be, it's for short-term use, it's not going to be committed to state. All of an ephemeral resource's attributes are also ephemeral by extension, and an ephemeral resource can also consume other ephemeral values. Let's make that a little bit more concrete with a quick example. So very recently, the AWS provider shipped support for an ephemeral resource that can retrieve the value and also metadata associated with a secret that is managed by AWS Secrets Manager. Once this secret value is loaded into memory, you can use it elsewhere in your configuration. You can reference that to spin up a PostgreSQL database, for example, without worrying about the actual secret being persisted to state. Write-only attributes for managed resources, which is part of Terraform 1.11, takes things to the next level. Ephemeral contexts enable practitioners to indicate that something shouldn't make it into state, but write-only attributes go even further and enable provider authors to indicate that a value can only ever be set, never read back. So in real life, we can think of situations where this kind of pattern would be useful, right? Such as creating a password. You want to write a password into the encrypted database one time and never read it back out as plain text. The write-only attributes feature empowers provider authors to clearly indicate to practitioners where Terraform will never ever be persisting a value. Soon you'll see lots of examples of values that are first defined ephemerally or perhaps generated ephemerally and then passed into a managed resource to be used as a write-only attribute. Write-only attributes will very often be used in conjunction with ephemeral values we expect, but they actually don't need to have a one-to-one mapping. Providers may supply a write-only attribute for things that are not actually sensitive, but maybe that's just something that Terraform doesn't need after it's been set up. Write-only attributes will ship in many of our official providers around the same time as Terraform 1.11. If you want to learn more about ephemeral resources and write-only attributes, check out these links. The second link here is a recording from a workshop that's targeted towards provider authors. So if you would like to learn how to use these features in your provider, check out that second link. I also want to give one more very quick shout out to Terraform Stacks, which was another big project that we worked on this year. Although Stacks is not a community edition feature, it solves a really big problem for everyone using HCP Terraform. Terraform Stacks enables practitioners to declaratively perform multi-phase Terraform apply operations, which lets Terraform resolve order dependencies intelligently and without practitioner intervention. So to learn more about this, go check out Ned's talk from earlier in HashiTalks, and also Sarah's presentation from the HashiConf main stage from October.
That was a lot of new feature work for 1 year. Now let's take a look ahead at what's next. When we make decisions about what to build next, we're always trying to solve the biggest problems for Terraform end users. But how do we define what qualifies as a big problem? Of course, we're looking at GitHub issues and the Discuss forums. There are thousands of open issues in the Terraform repository and thousands more upvotes and comments in those open threads. We know that there are a lot of things that people still want Terraform to do, and we hear you. We are chipping away at these things bit by bit. But we are also looking ahead to the next 5 to 10 years of managed infrastructure at scale. And when you take that view and start asking the question, what's down the road for Terraform? How will people be using our tools in a decade from now? Well, that leads to a lot of interesting questions.
One theme we're exploring right now is around unmanaged infrastructure. The only tool that practitioners have today to bring existing infrastructure under Terraform management is import. You can manually import an EC2 instance that someone made in the AWS UI into Terraform configuration, for example. Import is powerful, but it's a very, very fine-grained tool. You have to know exactly what's on the outside, and you have to know exactly where you want it to live when it comes inside. It runs into limitations when you're reasoning about hundreds or thousands of unmanaged resources, or how we like to think of it as resources that are not yet managed by Terraform. So this is an area that we're actively exploring and developing. Our bet here is that if we can tell a better story about bringing the unmanaged world of infrastructure into Terraform, then we can empower practitioners to much more easily maintain all of their infrastructure that their organization needs to be successful.
The second big theme we're exploring this year is around going beyond CRUD operations. So everyone knows by now that the Terraform resource lifecycle is about creating, reading, updating, and destroying remote resources, or CRUD operations. And Terraform over the last decade has settled on some great conventions around writing declarative configuration. It's easy to write HCL that communicates your intention. Modules enable teams to package up and share their sensible defaults. And you can easily reference other objects because everything has a name. In fact, these quality of life features are so useful that, well, wouldn't it be amazing if they could be used for just modern CRUD operations? What would it mean for Terraform to evolve beyond just creating, reading, updating, and destroying? In the real world, there's a ton that happens in between. For example, CloudFront caches occasionally need to be cleared out. Databases need to be backed up and restored. Or maybe rolling upgrades need to be performed across a fleet of instances. If you look at the API documentation for any infrastructure resource, there's a lot more than just CRUD. So we're exploring this area and we're looking into ways to leverage Terraform's existing user experience for practitioners towards greater extensibility into other API operations. If you heard anything today that resonates with you, we mean it when we say that we want to hear from you. We're actively looking for end user feedback to help us shape the solutions we build. We have a new email that you can now use. Send us an email at chat-terraform@hashicorp.com and we will read it and get back to you.
Thank you so much for your time today. I hope this was useful. I hope this was interesting. And thank you so much, the HashiTalks team, for having us. Enjoy the rest of your day.